This is section 12.5, and we're going to talk about the derivative of log functions, and that's both log and ln, the natural log. So the four rules are here. The logs are separated, the logs got separated, but the derivative of the log base a of x is 1 over ln a x. So again, you can just follow the rules. They're pretty straightforward. The derivative of ln x, well, let's do this. We did the log base a of x. Let's go down here. If it's log base a of something other than plain x, that you can write the derivative by u prime. That means the derivative of this over ln a u. So it resembles this, but you do have to, you end up multiplying by the derivative of u. So it's just easy to remember u prime goes on top and that goes there. Then the derivative of ln x is 1 over x. The derivative of ln u is 1 over u times u prime, or you can just remember u prime over u. So that may be the easiest way to remember that one. Let's look at a few examples. So if f of x is 6x, that's 1 times 6x, and you go back here, I don't know, this should be ln. I guess that got erased. Hold on. Okay, so I fixed that, sorry. So that's ln of 6x. And so if we're just following the rules, that's the same as ln u, because it's not just plain x. So it's 1 over 6x times the derivative of u. So remember, we're here. Or we could just say, okay, the derivative of 6x is 6 over the original 6 over 6x. It does clean up, and we have 1 over x is our final answer. All right, now this example, f of x is ln of x squared plus 1. And so that's ln of u. So what's the derivative of this? The derivative of this is 2x over the original. This is what's happening, but you can just actually say, what's the derivative of this? It's 2x over the original. Log base 2 of this, so that's log base a of u. That's here. So u prime, what's the derivative of this? That's 6x minus 4. That goes on top. On the bottom, I'm showing you the rule, it's ln a, so ln 2 times whatever u was, which is 3x squared minus 4x. So you just have to follow the rules. Let's go look at our problems. I think we only have 5. All right, so number 1, f of x is ln of 16x. Well, remember, it's the derivative of this, so 16 over 16x, that's going to simplify to 1 over x. ln of 2 minus 7x. What is the derivative of this? It's negative 7 over 2 minus 7x. They really want the negative out front, so I think MathLab will like this answer. You could get away with having the negative up here as well, but just think about that. Number 3, ln of this radical. Well, we don't want to deal with the radical. We want to rewrite it so it's a fractional exponent. Remember, there's an understood 1 and an understood 2. So y equals ln of x plus 1 to the 1/2. So it's 1 over that original times the derivative of what is there, x plus 1 to the 1/2. So it's that times, now if we take the derivative here, remember this is where we're taking the derivative. So 1/2 goes to the front, and then we have a negative 1/2 left as the exponent. So let's think about everything that's on the bottom. We have a 1, both places, 1's on the top. This 2 is on the bottom. This denominator is on the bottom. This goes to the bottom and now has a positive 1/2. if you are multiplying things and they have the same base, you add the exponents. Well, 1/2 plus 1/2 is simply 1. So you end up with 1/2 times x plus 1. All right, number 4. Y equals ln of this to the 7/3. So you have 1 over that expression times, now we need to take the derivative of this. 7/3 comes to the front. We have 7x cubed plus 2x. Now from 7/3 we need to take 3/3 because we're taking away 1. That leaves 4/3. And because of the chain rule, then we've got to multiply by the derivative of this, which is 21x squared plus 2. All right, so we've got 7 is on top, this is on top, this is on top. The 3, this 7/3, 7 on top, 3 is on the bottom, and this to the 7/3 is on the bottom. Now, we can, because these two are very similar, we can go over here and do the algebra. That's 4/3 minus 7/3. We're subtracting those exponents. And we're left with this function in here to the negative 3/3, which is a negative 1. So now that's going to go to the bottom. So our final answer, we have 7 on the top. We have this on the top. This in the middle here has all become just one of these 7x cubed plus 2x, and the 3 is on the bottom. So this is what we have for the final answer. It was just this algebra in here that we used to clean up this middle part. All right, our last one. The algebra of this gets a little confusing, but hopefully you can follow this and then use that when you encounter that homework type problem. So this is our original problem. It is a quotient because this is a function of x, this is a function of x. So we are going to use the quotient rule. All right, so for the quotient rule, the bottom times the derivative of the top minus the top times derivative of the bottom, all over the bottom squared. So that line is your roadmap. In this line, we're going to take some derivatives. 4 ln x plus 3, the derivative is 4 over x plus 3, minus that times 2x, all over x to the 4th. Now, the algebra for this, to make it a little easier to clean up, if we multiply the top and the bottom by x plus 3, that's going to get rid of this fraction in here. So just think about if I'm multiplying the top up here, it's going to cancel out with that one. And then I've got it down here because I multiplied it times this as well. So now I have 4x squared minus 8x times x plus 3, because I had to multiply it both there and there. And then ln x plus 3 over x to the 4th times x plus 3. What that did was get rid of our fraction here. Now we're going to factor x out of the top and the bottom. If I take x out here, I'm left with 4x minus 8, because I took the x out here, x plus 3, ln x plus 3. All right, so I took x out of this piece and left 4x. I took x out of the 8x and left 8. I took x out of this, and I've got x cubed times x plus 3. Well, what that allows me to do is now cancel those out, and then I'm left with my answer. So really it was just some algebra to rearrange things and clean it up as best we could. This is our final answer. And that should get you through 12.5.